Now, one thing that I often find third years and indeed sixth years really struggle with is working with fractions. So in this video, we're going to just go through a number of different questions. Some of them we're going to simplify, some of them we're going to solve, and we're just going to talk about the different rules that apply when dealing with fractions. Let's first of all talk about how we could simplify 3 over 4 plus x over 3. If you are adding or subtracting fractions, then you should get a common denominator. The common denominator is the smallest number that both of the denominators will divide into. What's the smallest number that 4 and 3 will divide into? And in this case, it's 12. Often, the common denominator is just found by multiplying the bottoms by each other. 4 by 3 gives me 12. So my common denominator here is 12. And now I would ask myself, how many times does 4 divide into 12? 4 divides into 12 3 times. So it'll be 3 multiplied by whatever's on the top of this fraction. The thing on the top of the fraction is a 3. And then I would look at the second fraction, there's a plus between them, and I'd ask myself, how many times does 3 divide into 12? 3 into 12 goes 4 times, so it's going to be 4 times whatever's above the 3, which is an x. So if I simplify this one fully, I end up with 9 plus 4x divided by 12. And that's adding or subtracting fractions. Now obviously as we go through this video, it's going to get a lot trickier and it's going to look a lot more difficult than that. But whenever you're struggling adding or subtracting fractions, just think about this basic example, and this is your default setting when you're dealing with fractions. Okay, now the second example here, this is the main reason that I actually want to do this video, just revising fractions. This is really, really important. In a number of different cases, as we go through the course, you're going to end up with one fraction divided by another fraction. You never want to have one fraction divided by another fraction. It's too complicated. So I want to talk to you about how you could solve something like this. In any section that we do for the rest of this course, if you have one fraction divided by another fraction, you change it. You take the fraction on the bottom, and instead of dividing by this fraction, you can flip the fraction and multiply. So let's just rewrite the fraction on the top here. I have x plus 3 over 2x plus 7. Instead of dividing that fraction by this, I can flip the fraction and multiply. So at the moment, another way of writing this, another way I could write it is I could write it as divided by x plus 3 over 4x plus 14. That's simply another way of writing it. But I never want one fraction divided by another. Instead, you flip the fraction and multiply. So this means exactly the same as multiplying by 4x plus 14 over x plus 3. Now, it is incredibly straightforward to multiply fractions by each other. You don't need a common denominator, you don't need anything like we did in example 1. If you're multiplying fractions by each other, you simply multiply the top of the fraction by the top and the bottoms together. However, in this case, you should notice that you have an x plus 3 on the top and an x plus 3 on the bottom. So the x plus 3 on the bottom divides into the x plus 3 on the top once, and essentially I can cross them out. I can rewrite this as 4x plus 14 divided by 2x plus 7. Now, if I have a 2x plus 7 on the top, I'm noticing some kind of a relationship here between the bottom and the top. So what I can actually do is I can factorize the top of this fraction. I could rewrite the top of this fraction as 2 times 2x plus 7. If I simply factorize 2 out of the top, then I'm left with 2 times 2x plus 7, and I have 2x plus 7 on the bottom. And in this case, once again, the 2x plus 7 on the bottom divides into the 2x plus 7 on the top once, and my final answer here is 2. So I'm going to give you a number of questions, a number of quite difficult questions that are derived from this concept. If you have one fraction divided by another, you flip the fraction and multiply. Okay, the last example I'm going to do before I give you a number of questions is this one. This time we have an equation as opposed to an expression. What that means is this time there's an equals involved, which means we can solve it. We can now actually find the value of x. In this case, we have x over x minus 1 plus 1 over x plus 1 is equal to 1. The way that you should view this one is you should view this one as if you're adding and subtracting, but you've 3 fractions this time. In a scenario like this, probably the easiest thing to do is to get a common denominator for the whole thing. So to get a common denominator, when the denominators have algebra in it, like I have to think of the smallest number that will divide, that x minus 1, x plus 1 and 1 will all divide into. The easiest way to do that is to actually just multiply all the denominators by each other. If you have algebra on the bottom of one of your fractions, your common denominator, you literally just list out all of your denominators and you multiply them by each other. So it's just x minus 1 times x plus 1 times 1. Obviously, I don't need to put in the 1 because multiplying by 1 doesn't actually change the value. And now think back to what we did at the very start of this video. First of all, I need to figure out what to multiply the x by. So I have to ask myself, how many times does x minus 1 divide into the common denominator? If I divided x minus 1 into what I have on the bottom here, it would cancel with itself and I'd be left with x plus 1. Which means that it's going to be x plus 1 times whatever's on the top of the fraction. In this case, on the top of the fraction is an x. There's a plus between them, so I'm going to put a plus here. And now I have to ask myself, how many times does x plus 1 divide into the common denominator? X plus 1 into the common denominator is going to go x minus 1 times. And I need to multiply that by whatever's on the top. It's a 1, so it doesn't actually change the value. And then I put an equals here, and I ask myself, how many times does 1 divide into the common denominator? 1 into 5 goes 5 times, 1 into 10 goes 10 times, so 1 into anything, I just rewrite it. So 1 into my common denominator is just x minus 1 times x plus 1. And then I'd have to multiply that by the top of the fraction, which again, it's just a 1, so I don't actually need it. Now the reason that this is useful is because if you have a fraction with an equals on the top of the fraction, you can just ignore your denominator. You can just ignore it. And now I'm just left with the top. I multiply x by x plus 1, and I would get x squared plus 1x. 1 by x just gives me 1x. 1 by minus 1 gives me minus 1. Now, you'll multiply this out as double brackets. X times the second bracket minus 1 times the second bracket. And when you multiply it out, you're going to get x squared minus 1. You should now move all of your terms to one side. If you have an x squared, an x, and a number, I want your instinct to be to move everything to one side. Except in this case, something strange is going to happen. I already have an x squared here. When I bring this across, I'm going to get a minus x squared. I have 1x plus 1x, and that gives me 2x. And I've got minus 1. When I bring this minus 1 across, it's going to become a plus 1. So I've moved everything across, which means it's equal to 0. I have plus x squared minus x squared. I have minus 1 plus 1. Which means that I'm actually just left with 2x equals 0. If 2x is equal to 0, then x must also be 0. I could just divide both sides by 2, and I just get x equals 0. So really, I just wanted to show you how we work through these kinds of questions. Okay, now this is the only completely new thing you're going to see in this video. Arguably, this is not directly related to algebra, although it's really important for other topics we're going to do in the Leaving Cert High Level course, like trigonometry and complex numbers. If you plug 4 over 2 minus root 3 into your calculator, you'll get the answer to this question straight away. Your calculator is programmed to never give you a surd on the bottom of a fraction. However, you could be given a question where you have something like this and you need to eliminate the surd on the bottom of the fraction, but you're not allowed to use your calculator. So I want to go through here how we could deal with this. If the problem at the moment is there's a root 3 on the bottom of the fraction. If you've 2 minus root 3, I need to figure out what can I multiply that by so that the surd so that there be no more surds. What I need to do is multiply 2 minus root 3 by what's called the conjugate of 2 minus root 3. To get the conjugate of 2 minus root 3, you change the sign in front of the surd. So 2 minus root 3 multiplied by 2 plus root 3. If I multiply that out as double brackets, the surds are going to, I'll have no more surds, they're going to cancel each other out. But I can't just randomly multiply the bottom of a fraction by 2 plus root 3. If I'm multiplying the bottom by that, I must also multiply the top by that. Because look at what I'm doing now. I'm multiplying by 2 plus root 3 over 2 plus root 3. That's like multiplying by 5 over 5 or 10 over 10. If the same thing is on the top and the bottom of the fraction, what I'm actually doing is multiplying by 1, which means I'm not changing the value of the expression. So I want to eliminate the surd on the bottom of the fraction, so I need to multiply this by its conjugate. And then I need to multiply the bottom and the top by the conjugate, so I'm not actually changing the value of the expression. So that's what we're going to do whenever we have a surd on the bottom of a fraction. Now if we just look at this, the top of the fraction is now going to be just 4 times 2 plus root 3. And if I multiply in the bottom, this is just like double brackets. The first thing in the first bracket by the second bracket, and then the second thing in the first bracket by the second bracket. Let's just multiply this out and see what happens. 4 by 2 gives me 8. 4 by root 3 just gives me 4 root 3. It's the bottom of the fraction here that's really, really important. If I multiply 2 by 2, I get 4. 2 by root 3 just gives me 2 root 3. Minus root 3 by 2 gives me minus 2 root 3. Minus root 3 by plus root 3 just gives me minus 3. Look at the two middle terms on the bottom of the fraction. Whenever I multiply 2 minus root 3 by its conjugate, or anything in that form by its conjugate, the middle terms will always cancel each other out. 2 plus root 3, I've plus 2 root 3 and I've minus 2 root 3, which are going to cancel each other out. And now I'm just left with 8 plus 4 root 3, and on the bottom I have 4 minus 3, which is just 1. And now that's it simplified, because there's no surd on the bottom of the fraction anymore. In fact, if it's all over 1, I don't even need to write it as a fraction. So in a number of different things that we do in this course, we're going to come across scenarios similar to this, where you have a surd on the bottom of the fraction, or in complex numbers, again, it's going to look a little bit different, but it's going to be the same concept. So I'm going to give you just, among the questions we do in this video, I'm going to give you just one of those that I want you to practice. Notice that if you just plug that into your calculator, you get the answer straight away. But often in the marking scheme, we'll say that you need to actually show your work. Obviously, it'll explain that in the question, but often you won't be allowed to just plug it into your calculator and get the answer. Okay, so I'm going to give you two questions here. The first question has 3 different parts to it. You're given 3 fractions, and in each case you need to simplify it. The first one, the top of the fraction is a plus b, while the bottom of the fraction is 1 over a plus 1 over b. I'm not going to give you any hints there. I want you to just deal with it yourself. I want you to simplify that fraction. The second one, I have 27x cubed plus 125 over 9x squared plus 30x plus 25. For that one, you should factorize the top and the bottom and then simplify it. And the third one, we've minus 4 over minus 3 plus root 5. In this case, you need to try and eliminate the surd from the bottom of the fraction. So you're going to have to multiply the top and the bottom by the same thing. So I want you to pause the video now and take these down, and then take down question 2 and work through the questions. Okay, the second question, I'm giving you 2 parts, and in each one I want you to solve to find the value of x. So in each case you've got fractions. I want you to see if you're able to deal with those. So pause the video now, try question 1 and question 2, and then compare it to my solutions. The first part of question 1 here, I asked you to simplify a plus b divided by 1 over a plus 1 over b. In this case, on the bottom of the fraction, you've got 2 fractions that you need to add together. In order to add or subtract fractions, you get a common denominator. The common denominator for 1 over a plus 1 over b, in that case the common denominator is a multiplied by b. And now I should ask myself, how many times does a divide into the common denominator? A divided into ab, well, a would divide into itself and I'd be left with b. So it's b times whatever's on the top of the fraction, which is just a 1. There's a plus between the 2 fractions, and then I would ask myself, how many times does b divide into ab? B divides into b, and then I'm left with a. So it's a times the top of the second fraction, which is a 1. So it's just a times 1. So 1 over a plus 1 over b can be rewritten as b plus a over ab. And that's only the bottom of the fraction, because on the top I have a plus b. Now you never want more than one fraction line. You do not want this. At the moment I have a plus b divided by a fraction. Instead of dividing by a fraction, you can flip the fraction and multiply, so you multiply by the reciprocal. So at the moment I have a plus b on the top, and instead of dividing by this fraction, I'm going to multiply and I'm going to flip the fraction. So multiplying by ab over b plus a. Now in this case, I should view this as a plus b over 1 multiplied by ab over b plus a. In this case, you have a plus b and b plus a. They're obviously the same thing. B plus a divides into a plus b once, and I'm just left with ab. So if I simplify that, I'm simply just left with ab. So that was part 1 simplified fully. Okay, in the second one, we just had to practice our factorising. The top of the fraction, we had 27x cubed plus 125. You need to recognise that that could be rewritten as 3x all to be cubed plus 5 all to be cubed. In the previous video, we've explored how to factorise the difference of two cubes. The sum of two cubes. And if you do that in this case, if you factorise this, you get 3x plus 5 times 9x squared minus 15x plus 25. The bottom of the fraction, we had an x squared, an x, and a number, which is simply a quadratic equation. If you factorise it, you get 3x plus 5 times 3x plus 5. Once you've factorised the top and factorised the bottom, you should realise that one of the 3x plus 5's on the bottom will divide into the 3x plus 5 on the top once. And your final answer is this. Realistically, if you got this, you'd probably then attempt to factorise the top again, because the top of the fraction is a quadratic. But if you try and factorise this one, you'll notice that there are no factors, there are no real roots to this quadratic, so we can just leave our answer like that. That's our fraction simplified. Okay, so part 3 is the new thing that we haven't seen before from this video. In a number of different sections in Leaving Cert higher level maths, we're going to come across scenarios where we have a cert on the bottom of a fraction. You could simply plug that into your calculator and you'll get your final answer. However, there are questions where they force you not to use your calculator, and you need to know how to eliminate a cert on the bottom of a fraction. In order to get rid of the root 5 on the bottom of this fraction, I need to multiply minus 3 plus root 5 by its conjugate minus 3 minus root 5. But if I multiply the bottom by that, I must also multiply the top by that. So if I multiply the top and the bottom by minus 3 minus root 5, then I'm multiplying by 1, because if it's the same thing on the top and the bottom of the fraction, I'm not actually changing the value of the expression at all, I'm multiplying by 1. So it becomes minus 4 times this bracket on the top, and then here I just have double brackets. So it's the first thing in the first bracket by the second bracket, second thing in the first bracket by the second bracket. When I multiplied it out, the key here, I want you to look at what happens on the bottom. Minus 3 by minus 3 is 9. Minus 3 by minus root 5 is plus 3 root 5. Root 5 by minus 3 is minus 3 root 5. And root 5 by minus root 5, well, plus by minus is minus, and root 5 by root 5 is 5. This is the important bit. The reason I'm doing this is to eliminate the cert on the bottom of the fraction. And that if I multiply minus 3 plus root 5 by what we call its conjugate, in other words, its conjugate, you just change the sign in front of the cert. If I multiply this by its conjugate, then the middle terms will cancel and the certs are gone. That's the whole point of doing this question. And then on the bottom, I just have 9 minus 5, which gives me 4. And at this stage, 4 goes into 12 3 times and 4 goes into 4 once. So my final answer is simply 3 plus root 5. Now, that's going to come up a lot in trigonometry and in complex numbers, but it's useful for you to have seen that at this stage so that when it does come up, you'll recognise it and you'll be able to deal with it. Okay, so question 2, part 1, we were asked to solve. We've 2x minus 5 over 3 equals x minus 2 over 2. Now, there are a couple of different ways of doing it. I'm sticking with the concept of getting a common denominator here. If I have two fractions and equals in between them, one way of doing it is to get a common denominator. The smallest number that 3 and 2 can divide into is 6. And then I'd ask myself, how many times does 3 divide into 6? It goes in twice, so it's 2 times whatever's on the top of that fraction. Then an equals between them, 2 divides into 6 3 times, so it's 3 times x minus 2. If you have an equals on the top of a fraction, you can just ignore the bottom and ignore the 6. Now, I'm sure there's a lot of you looking at this video thinking that you wouldn't have bothered to do that at all. If you have two fractions and an equals in between them, you can actually just jump straight to this line. You don't even need the common denominator there. You could just ignore that. You could literally have just went from this line to this line. Often, a lot of students think of it as cross-multiplying. It's essentially the same thing as getting a common denominator. If you have two fractions and an equals in between them, you can simply say that the top on the left by the bottom on the right is equal to the top on the right by the bottom on the left. So 2 by 2x minus 7 equals 3 by x minus 2. You're allowed to go straight from this line to this line. I just wanted to show you that it's actually what we're doing there is we're actually just getting a common denominator. And at this stage, you just multiply it out, and I moved all my x's to one side, my numbers to the other side, and I ended up with x is equal to 4. So let's have a look at the second part of this question now. Okay, the second part of this question was slightly more difficult because we have three separate terms. We have 5 over x minus 2 minus 3 over x plus 2 is equal to 2. And notice I've written that as 2 over 1 because I want to just think of it as a fraction. If you're adding or subtracting fractions, you should get a common denominator. So I got a common denominator here of x minus 2 times x plus 2 times 1. And that's what I put on the bottom of the fraction. And then I have to ask myself, how many times does x minus 2 divide into the common denominator? It would divide into itself and I'd be left with x plus 2. So it's 5 times x plus 2. Then I put a minus between them and I ask myself, how many times does x plus 2 divide into the common denominator? X plus 2 divides into the common denominator x minus 2 times. So it's x minus 2 times the 3. And then there's an equals between them and I have to ask myself, how many times does 1 divide into the common denominator? 1 divides into this, x minus 2 times x plus 2 times. So I multiply that by 2. When I multiplied out the top, it ended up simplifying down to 2x plus 16. When you multiply x minus 2 by x plus 2, you get x squared minus 4. Obviously, you can multiply that out as double brackets. I've skipped that line in the middle. And then it's 2 times that, which gives me 2x squared minus 8. And at this stage, I notice that I have an x squared, an x, and a number. So I recognize that I have a quadratic equation here. I moved everything to one side, and I ended up with 2x squared minus 2x minus 24. Before factorising this, I've divided everything by 2, and I've got an x squared minus 1x minus 12. I'm now going to take it from the top here and factorise and solve this quadratic. But as we go through the rest of this course, it's really, really important that you're confident at factorising quadratics. You will have a number of quadratics to factorise in your Leaving Cert higher level exam, so you need to be confident with it. When you factorise this one, you should get x plus 3 times x minus 4. You let each factor equal to 0, and the two possible values for x are x equals minus 3 and x equals 4. So that's all I wanted to talk to you about in terms of fractions. Most of this is actually revision from the Junior Cert, but obviously we're going to build on that over the next couple of videos, and we're going to look at new types of fractions that we have to deal with.